Hello friends, in this session we are going to discuss regarding the water disinfection techniques. As you know that in the water treatment plant, after uh, filtration of the water is disinfected. Now what kind of disinfection technique that to be used in the or that water treatment plant is decided on the characteristics of the water. So today we are discussing the various disinfection techniques. Now, in this session, we are going to discuss regarding the disinfection techniques, ozonation, ultraviolet radiation, um, chemistry of chlorination, chlorine demand curve, types of chlorination, application of chlorine, etc. Now, some common waterborne diseases prevented by disinfection. Now, if you see the diseases which are causing, these are because of the mostly three categories because of bacterial, viral, and protozoa. In the bacterial diseases, typhoid fever, paratyphoid, bacterial diarrhea, chlorea, and in viral hepatitis, rotavirus, diarrhea. Okay, in the protozoa, amoeba then gyardiasis, then cryptosporidiosis. So likewise, various diseases are there which are because of these various categories. Now let's have the glance on this disinfection process. The purpose of disinfecting drinking water is to destroy organisms that cause diseases in human beings. Most pathogenic bacteria are removed from water in varying degrees during the different treatment processes, coagulation, sedimentation, and filtration. Disinfection is used to ensure satisfactory removal of pathogens from potable water. Suitability of disinfectant. The disinfectant shall be effective in killing the microorganisms. It should be cheap and readily available, should be safe to handle and easy to apply. It should not make water toxic in nature. It should have ability to persist in residual state. Now, what are the various disinfection methods? Boiling, high pH, excess lime, silver treatment, potassium permanganate, chlorination, ozonation, UV radiation. So, other halogens also iodine and bromine. The first one is the boiling. Water shall be boiled at least for 3 minutes. It is the most effective method. It can kill bacteria and viruses. It cannot be used on large scale. During epidemics, it is used in a domestic scale. Second is a high pH treatment or excess lime. Lime can destruct the bacteria at high pH values. In this case, no residual will remain after neutralization, and studies shows that higher removal of viruses was obtained with higher pH values. Optimum pH in the range of 11.2 to 11.3. Optimum contact time in the range of 1.56 to 2.4 hours. Complete destruction of viruses was obtained at a pH of 11 and contact time of 5 hours and 10 minutes. Silver treatment. Silver when immersed in water has been inhibiting effect on bacterial life. As silver is costly, this method can be used in a small scale. Next one is a ultraviolet or UV irradiation. It can disinfect both water and wastewater. However, its use in drinking water disinfection is limited to the small installations such as abroad ships because of it does not produce residual. In wastewater treatment and when compared to chlorination and ozonation, UV was found more effective and more economical. UV irradiation is gaining prominence. So these two pictures you can see how these chambers are provided to pass on this ultraviolet rays, and how irradiation is carried out to disinfect the water. Okay, so this it is visible. Next one is the ozonation. General characteristics of ozone. It is a powerful oxidant, most powerful than hypochlorous acid, unstable in aqueous solutions, has a half of 20 to 30 minutes in distilled water, widely used in the drinking water treatment, is produced on site and cannot be stored on site. Remember, these are some parts with the ozonation. The next one is the potassium permanganate, commonly used in the rural areas, used for the purification of open well water supplies. Then KMNO4 is dissolved in a bucket and added in the well water. Okay, KMNO is a chemical formula for this. Water should not be used during for first 48 hours after KMNO4 addition. Now, mostly used method it is by chlorination. Now, why chlorination is carried out? Now, chlorine is widely used in the disinfection process, effective at low concentration, cheap. It is a cheap method. Forms residual if applied in sufficient dosages. Chlorine is applied as gas, most common, Cl2, and hypochlorite, bleaching powder, CaOCl2. Chlorine is a strong oxidizing agent. It oxidizes enzymes of microbial cells that are necessary for metabolic processes, thus inactivating, destroying the microbial cells. Chlorination reaction. Chlorine gas reacts with water to form hypochlorous acid HOCl and hydrochloric acid as HCl. If you see the reaction Cl2 plus H2O, that gives HOCl plus HCl. Now this HOCl, it is hypochlorous acid dissociates to hypochlorite ion. Okay, HOCl further H plus OCl minus. So the dissociation of HOCl is a function of pH. Hypochlorous acid is 80 times more effective disinfectant than hypochlorite ions. Chlorine will appear in water in three forms: elemental chlorine, Cl minus, HOCl and OCl minus. Now this graph shows the percentage of this hypochlorous acid against the pH value. So the graph is obtained like this, right? So depending upon the pH, how this percentage of OCl minus and the percentage of OCl that effective in the disinfection. At the same time, the temperature has been also noticed here. Okay. So this table shows regarding the pH and its effect. So less than 5, only elemental of molecular chlorine is present. If the pH is between 5 to 10, both HOCl and OCl minus present, and greater than 10, only hypochlorite ions are present. So below pH 7, concentric acid of HOCl is more present there. pH of water should be less than 7 to prevent ionization of hypochlorous acid. Now chlorine demand. Now what is chlorine demand? When chlorine is added in water, it reacts with organic and inorganic impurities. The amount of chlorine utilized for this is known as chlorine demand. The remaining chlorine will appear as available residual chlorine, which serve as disinfectant to kill the pathogens. Now some terms regarding the dosages, demand and residuals. Now what is dosage? The amount of chlorine added. What is demand? The amount of chlorine needed to oxidize materials or reaction. Residual, the amount of chlorine remaining after oxidation. So residual chlorine is equal to dosage minus demand. So please remember this. Forms of application of chlorine. Chlorine can be applied in water by following forms: as bleaching powder or hypochlorite, as chloramines, as free chlorine gas, as chlorine dioxide. Bleaching powder. Chemical formula is CaOCl2. Available chlorine is 20 to 40%. When it is added in water, the following reaction takes place. So CaOCl2 plus H2O, so forms 2HOCl plus CaOH2. So this is a hypochlorous acid, acts as a disinfectant. As it contains 20 to 40% chlorine, it requires higher transportation cost and space for storing. Therefore, used for small scales, uh, that is rural water supply schemes. Chloramines. The free chlorine can react with compounds such as ammonia, proteins, amino acids, and phenols that may be present in water to form chloramines and chloroderivatives, which constitute as combined chlorine. Combined chlorine processes disinfection properties. Now here you can see the reaction with ammonia. So this NH3 plus HOCl, it is given NH2Cl plus H2O. It's associated with the monochloramine. Then NH2Cl plus 2HOCl gives NaCl2 plus 2H2O dichloramine, and NaCl2 plus 3HOCl NCl3 plus 3H2O, so nitrogen or trichloride. So again pH range and the chloramines form. So less than 4.4, if the pH is less than 4.4, trichloramine only. 4.4 to 5, dichloramine only. So this is the formation here. So 5 to 8, both mono and dichloramine will form equal quantities at pH is equal to 7, and pH if it is greater than 8.5, monochloramine will only form. Now, what are the advantages of this process? More effective than chlorine alone, prevents taste and odor. Water treated with chloramines causes less irritation of eyes and odors. No danger of overdose. Less chlorine is required. Now next is a free chlorine, generally applied in gaseous form or liquid form, 2.48 times heavier than air and 1.44 times heavier than water. It is a strong oxidant. It forms residuals. Byproducts are formed, for example, THMs, and work under the pH, specific pH. Then chlorine dioxide, ClO2. Chlorine dioxide is created by mixing solutions of sodium chloride and chlorine itself. The chlorine dioxide is generated on site 2NaClO2 plus Cl2, that is given 2ClO2 plus 2NaCl. So the advantage of the chlorine dioxide are it is strong bactericide and viricide over the wide pH range. It forms a slight residue in the distribution system. It does not react with the nitrogen to form chloramines. It does not react with the organic matter to form trihalomethanes, as I said that THMs. Chloroform and bromoform are THMs. The disadvantage of chlorine dioxide are its high cost and its tendency to create chlorate and chloride, which are potential toxins. Chlorine dioxide is used for taste and odor control as well as disinfection. Now, what are the forms of the chlorination? Plain chlorination, pre-chlorination, post-chlorination. double or multiple chlorination, breakpoint chlorination, superchlorination, and dechlorination. So all these are the forms of the chlorination. Now, what is plain chlorination? Application of chlorine to raw water before it enters into distribution system, sometimes added to reservoirs to check the growth of weeds, organic matter, algae, etc. It can be practiced for water with turbidities 20 to 30 NTU. Dose range, it is 0.15 to 1 ppm parts per million. Okay, and this is the nephelometric turbidity unit. Then second is a pre-chlorination. Chlorine is applied before treatment, especially before filtration, sometimes added before sedimentation. Advantages: reduces bacterial load of filtration, reduces coagulant required, controls growth of algae, and eliminates taste and odors. Third is the post chlorination. Addition of chlorine after treatment, that is after filtration, added before water enters into distribution system. Double chlorination. Application of chlorine at 2 or more points in purification process, usually added before sedimentation time, after filtration. This is done in if water is more contaminated. Breakpoint chlorination. When chlorine is added, it reacts first with the reducing compounds such as Fe2, Mn2, NO2, and the chlorine will be reduced to non-effective chloride ion Cl minus from 0 to point A on the scale, remember. When adding more chlorine, it will react with NH3 to form chloramines in the chlorine chemistry. Now there is a various points are there. When adding more chlorine, some chloramines are oxidized to nitrogen gas and the chlorine is reduced to non-effective Cl minus ion. Continued addition of chlorine will produce free available chlorine, so which is called as a break point. Okay, if you see this particular graph which is plotted, again chlorine dose and this chlorine residual. So from A to B, you can see the chlorine combined residuals are there. From okay, B to C, again the drops there. This is a break point, and again from C onwards you can observe the free combined residuals are there, right? Next one is the superchlorination. Chlorine is applied beyond breakpoint. It is done after filtration with contact time of 30 to 60 minutes. It is practiced when there is a epidemics in the society. Dechlorination, the process of removing excess chlorine from water, it is known as a dechlorination. It can be achieved by aeration using chemicals such as sodium thiosulfate, sodium bisulfate, sodium sulfite, activated carbon, potassium permanganate, etc. Now, which factors are there affecting this chlorination process? First one is the turbidity. Turbidity affects chlorination process as efficiency of disinfection process decreases if water is more turbid. Pathogens can shelter behind the solid particles. So chlorine added after removing turbidity, that is after filtration. Presence of metallic compounds. Fe and Mn consumes more chlorine if present in water. So chlorine is added when Fe and Mn are removed from water. Ammonia compounds. Ammonia forms combined chlorine compounds which are not so powerful disinfectants as compared to free available chlorine. Therefore, more chlorine is added so that after formation of chloramines, excess free chlorine is available for speedy disinfection. Fourth one is the pH of water. Increasing pH reduces effectiveness of chlorine. Now this table shows pH and amount of this hypochlorous acid or HOCl up to 6 to 6.7, 95% of total pre-chlorine. At 7, 80% of total pre-chlorine. At pH 8, 30% of total pre-chlorine, and at pH 9, 5% of total pre-chlorine. So it shows that increasing pH reduces effectiveness of chlorine. Temperature of water. Reduction in temperature decreases killing power of both free and combined available chlorine. Time of contact. Percent kill of pathogens depend upon contact of chlorine and microorganisms. Time of exposure of or time of contact is needed. Usually for free chlorine 10 minutes time is required as compared to 60 minutes for combined chlorine. Nature and concentration of bacteria and viruses. Bacteria spores are more resistant and poliovirus is more resistant. So some viruses are there more resistance to this process. So today friends we have discussed all the disinfection methods which are used mostly in the water treatment processes. So in the this process, what is important that the care is taken that mostly the disinfected water should be provided to the distribution system. So thank you very much for joining this session.